Hello and welcome. You ever wonder what makes your favorite apps and websites just feel instant? Well, today we're diving into the secret weapon behind all that speed. It's a fundamental concept that, honestly, makes the whole digital world go round. Okay, let's start with a number 100 milliseconds. It's literally the blink of an eye. Seems like nothing, right? But in the world of computers and system design, it can mean absolutely everything. Just let that sink in for a second. A delay so small you can't even perceive it was costing Amazon 1% of their sales. That is a wild figure, and it proves that when you're designing systems, speed isn't just some nice feature, it is a direct line to revenue. So, if a tiny delay can cost billions, how in the world do you fight it? Well, the answer is in this deceptively simple but incredibly powerful concept called caching. It is the key to building faster, more scalable systems. So what is a cache, really? At its heart, it's just a small, super fast storage layer. Think about it like this. Your main database is like a huge supermarket downtown. A cache, that's like having a little pantry in your kitchen with all your most used stuff. It saves you a long, slow trip every single time you need something you use often. And the difference it makes is just night and day. Without a cache, every single request, every page load hammers away at the database, creating this massive traffic jam. But with caching, a huge chunk of those requests get served instantly from that high-speed layer, which makes everything way faster and takes a ton of pressure off your main database. All right, so we know we need these shortcuts, but where do we actually put them? Let's trace the journey of a single data request to see all the different stops along what we can call the caching map. You see, caching isn't just one thing, it's a whole series of layers. A request might first hit a CDN, that's a content delivery network, which keeps things like images on a server physically close to you. If the data isn't there, okay, it might check a cache right in the application itself. And then finally, the database's own internal cache. See the pattern? Each stop gets you closer to the original data, but each step is also a little bit slower. And in a real-world system, oh boy, this can get incredibly complex. Take a social media newsfeed, for example. You might have one cache just for the list of post IDs, another one for the actual content of the posts, one for the social graph, who's friends with whom, and even separate little caches just for counting likes and replies. It's a whole ecosystem of shortcuts, all working together to create that seamless experience. But you knew there had to be a catch, right? This introduces a really critical challenge. A cache, by its very definition, has limited space. It's much, much smaller than your main database. That's part of what makes it so fast. So, what happens when you need to add a new, important item into a cache that's already full? Something has to go. The question is, how do you decide what gets the boot? This whole decision-making process is handled by something called a cache eviction policy. Honestly, you can just think of it as the bouncer for your cache. It's the algorithm that decides who gets kicked out to make room for new, more important data. And there are a ton of different strategies for this. For instance, you've got FIFO, or first in, first out, which just kicks out the oldest thing, no matter how popular it is. Then there's LFU, or least frequently used, which kicks out the thing nobody seems to want. And then there's one of the most common and interesting ones, LRU, or least recently used. So how does LRU work? It's actually beautifully simple. The cache just keeps a little record of when each item was last touched. When it gets full and needs to make space, it just looks for the item that's been sitting there, unused, for the longest time and discards it. The logic is pretty intuitive, right? If you haven't needed it in a while, you probably won't need it again anytime soon. Okay, so kicking things out of the cache is one part of the puzzle. But how we write data into the cache in the first place also involves some really important trade-offs, mostly between speed and making sure your data is fresh. This brings up a key choice you have to make. With a write-through cache, every time you update something, you write it to both the cache and the database at the exact same time. It's a bit slower, but you are guaranteed that the data is always consistent. On the other hand, a read-through cache is faster for writes. It only bothers loading data from the database when it's asked for and it's not already in the cache, what we call a cache miss. So really, the choice is between safety and speed. So it's really crucial to get this next point. Caching is so much more than just a speed boost for the user. Its impact on the entire system is absolutely massive.
Caching is not just some performance hack. It's a core pillar of modern system design. By acting as a shock absorber for the database, it lets you handle incredible amounts of traffic and scale up. It's what allows a system to handle a sudden, massive spike in users without completely collapsing, making the whole thing way more resilient.
And this really brings us to the fundamental dilemma of caching. You get this incredible performance, this amazing speed, but you always run the risk of serving stale, outdated data. So the constant challenge for any system designer is balancing that trade-off between raw speed and data consistency. And how you answer that question, well, that's the billion-dollar question, isn't it?